Last December, an incredible milestone in human history was achieved at the Lawrence Livermore National Laboratory in California. Curious to find out? They use massive lasers to squish hydrogen atoms together, producing energy just like the sun does. It's called nuclear fusion, one of the untapped areas of science. This was a big deal because scientists had been trying for a long time to make fusion happen in a controlled way. This success could eventually make fusion a new way to get power, which would be great for the environment. So if you are curious to know how they eventually did it and how we can benefit from it, this video is definitely for you. The National Ignition Facility is renowned for its immensely powerful lasers, capable of generating intense heat. After 13 years of relentless experimentation, their efforts bore fruit this past December. Remarkably, the energy output exceeded the energy input. This roughly indicates more than 100% efficiency in the production of energy. The leader of the fusion research, Tammy Ma, was really happy about it. They used extremely powerful lasers to focus on atoms of hydrogen. These lasers target tiny hydrogen-filled shells, meticulously constructed for even and controlled fusion implosions. Even though this is a big step forward, we still have more to do before we can use fusion for power. But this success in December made people feel hopeful that fusion could be an eco-friendly and unlimited energy solution. They made progress by using a thicker target that stayed stable and by finding ways to make the lasers stronger without breaking them. There's a picture of what they used before the experiment. Tammy Ma displayed an intact target assembly with a diamond shell inside a silver-colored cylinder. This assembly goes into a tall blue vacuum chamber filled with lasers and instruments. One tool, called Dante, measures extreme temperatures. The target assembly, like a historic artifact, will end up in the Smithsonian. The target cylinder was obliterated with the copper support peeled back. The resulting explosion was hotter than the sun and achieved record temperatures. Fusion, where atoms stick together, is very strong and safer compared to nuclear fission. But going from this achievement to making a power plant is still hard. They can only do a little over 1 fusion experiment a day right now, but for a real power plant, they would need to do about 10 experiments every second. They also need to make the experiments more powerful. A power plant would need 900,000 perfect diamond balls every day, along with better lasers. Even though the December success was a big sensation, they didn't talk a lot about how much energy they had to put in to get it out. President Biden wants fusion power in the country in 10 years, but some people aren't sure it's possible. There are big problems to solve, and they need to make success work on a larger scale. Private companies with lots of money are trying different ways to make fusion happen too. The head of Lawrence Livermore, Kim Buttle, thinks this project can work and wants to try again soon. Even though there are still challenges, Buttle believes they could have fusion power in about 20 years. It's like when the Wright brothers were trying to make airplanes. They showed it could work, and now we just need to figure out how to do it well. Shifting gears to the automobile industry, there's a notable transition from traditional fuels to sustainable electric energy. Major automobile manufacturers are racing to produce electric vehicles akin to Tesla's models, which heavily rely on special lithium batteries. While the US is rich in lithium reserves, its extraction has been relatively slow. But that's changing. They're starting to mine lithium in a place in California called the Salton Sea. They call it Lithium Valley because it's like a big treasure hunt, just like the gold rush. The Salton Sea is a big lake in California, and under the ground near it are valuable things like lithium. They think they can get more than 300,000 tons of lithium every year from here, which is more than half of all of the lithium they use in the world right now. CEO of the company Energy Source Minerals, Eric Spalmer, wants to get this lithium out of the ground. They're going to use an electric plant that's powered by heat under the ground. This is good for the environment, especially for making electric cars. They think they can make enough lithium for around 500,000 cars every year. The plan is to make 20,000 tons of lithium each year, which is enough for about 500,000 cars. The car company Stellantis North America, which makes brands like Chrysler and Jeep, thinks this is really important for the car industry. They're spending $35 billion to make changes and work on batteries. Lithium is really important for electric cars because it helps the batteries store a lot of energy. Getting lithium out of the ground is not great for the environment. Usually, they do it in places like Australia or South America. But this company wants to do it in a clean way, using the heat from the ground near the Salton Sea. They're going to use the heat from deep water to make electricity for homes. And they'll also use it to get the lithium out of the water. This is better for the environment and more efficient than other ways. People think they'll be able to use this clean lithium in the United States by 2025. Before they had to get it from other countries, but now they can get it here. More and more people want EVs like Teslas, so this is a big deal. There's a small version of the plant that shows how it works. It turns the orange water into a clear liquid with lithium in it. This shows that the big version will work too. The Salton Sea used to be a bad place because of pollution from farms, but now they've found something valuable under the ground. Some people worry about the environment and the community, but experts think there's enough lithium for a long time. Big car makers like Stellantis and General Motors are investing in this to make sure they have enough lithium for their cars. Most of the batteries are made in Asia, but now they can be made there, which is better for the environment and could make electric cars cheaper. The CEO of Energy Sources, Eric Spalmer, thinks this is really important and can help the world. He's happy that more people are investing in getting lithium from the United States. As of December 2022, leading scientists have urgently emphasized the need to combat worsening climate conditions, moving away from carbon-heavy fuels like oil and gas and pivoting to pioneering technologies such as direct air capture. This means taking bad stuff like carbon dioxide out of the air and putting it underground. They're already doing this at the Orca plant in Iceland, and to our surprise, it's working. Orca's chief technology officer, Carlos Hertel, explained how they use big fans to suck in air and take out the bad stuff. Then they put it underground. This isn't just a story, it's really happening, and it's helping fight climate change. Swiss company Climeworks, known for Orca, is developing a larger version in Iceland, 10 times Orca's size, easily assembled. This marks the start of a broader mission. In metal igloos, CO2 combines with water, entering Iceland's porous volcanic rock. Minerals transform CO2 into stone in years. CarbFix, led by geologist Sandra Oski, pioneered this in Iceland's harsh conditions. CarbFix accelerated this process. Engineer Carlos Harold sees Orca as a step, but rapid scaling is the challenge. Optimism and caution meet. Engineer Hertel is optimistic but wary as a citizen. Progress demands technological breakthroughs and societal will. Microsoft, Airbus, and Swiss must invest urgently. Orca removes emissions like those of 800 cars or 4,000 tons of CO2 per year. However, experts say 10 billion tons must be extracted annually, a moonshot-like challenge for our generation. Astrophysicist Carl Hegetilund envisions tankers fueled by green methanol transporting CO2 from Europe to Iceland for underground storage. Timing is uncertain. Hegeland stresses political, financial, and societal action alongside technology. Time is short. Direct air capture is costly and energy-intensive. In Iceland, due to geothermal energy reliance, elsewhere governments offer tax breaks. But can this breed complacency? Merely removing CO2 is insufficient. Emissions must decrease, and fossil fuels must be left behind. Swift action and existing carbon capture are vital. Using this technology to maintain the status quo is risky. Critics warn as oil firms adopt the technology. Opinions differ on oil collaboration. Occidental Petroleum aims to become a carbon management company, investing $1 billion in the world's largest direct air capture plant in Texas, offsetting emissions like 200,000 cars. CEO Vicky Holub aims for carbon-neutral oil production using captured carbon. She defends sincerity amid skepticism. Holub plans to add 130 more capture plants by 2035, backing words with action. Despite doubt, she sees the decade as crucial for this industry. CarbFix and Climeworks expand in the US without oil collaboration. The coming years will define direct air capture's global path. Are you ready to charge into the future of electric vehicles? Don't miss our next video on Tesla's game-changing innovations. See you there.